Welcome everyone to this first meeting of 2024. As you will all be aware, 2024 is a leap year, and by very good chance today is the 24th of January. So exactly one calendar month to today, it will be the 24th of February, which of course is the extra day in a leap year. 29th of February is merely the extra date. And if you don't know what I'm talking about, check out the meaning of bisextile years on Wikipedia or almost anywhere else will do. Now I'm going to share my screen, and I hope, yeah.
Oh. Yes, it's coming.
The wrong way round. There, that's for a start. This is simply to remind you that although it's 2024, it is for December 2023 bulletin that we are going to be looking through. And here, as usual, is the front cover of the December, of the bulletin we're going to be discussing. And at the bottom on the right, you'll see my email address. Please feel free to send me any comments or suggestions. And my favorite suggestion that you could possibly write is, please, I would very like to do the presentations myself instead of you. And a second best suggestion would be, well, I would like to give the occasional postscript at the end. Either of these suggestions would be very welcome. Failing that, here is the timetable, the table of contents for this issue of a bulletin. As usual, there are various entries that we probably won't be looking at, so let's remove them, the editorial and a couple of reports. And we'll be going through all these in turn, but I have highlighted here or indented three, which I think just might, just a hunch, lead to slightly more discussion than average. But that seems a good moment to introduce the lead article. So I go back to Martin's. I'll unshare my screen and just a minute. And Martin's will now show you the bulletin. And then I hope that Maciek will introduce the lead article, which he wrote. So over a couple of pages, that's the front cover. Then you see on the next page, the inside at front cover. And now we see this article. So, Maciek, perhaps you can say what motivated you, a little bit of backstory, please.
So I found this Sundial on a website of the auctioneer. I quickly noticed that it's a stereographic sundial and it has features typical for Elias Allen workshop, and decided to purchase it. And then John Davis kindly offered his assistance in analyzing it in terms of metallurgy. Then it was shipped to me. Then I made some initial restoration and research on the dial, and the next step was the restoration, which was conducted by Thorsten Hiller from Germany, from Brandenburg, and this turned out very successful. I have a few points that are not covered in this essay. So I will go through these. First, I'm not sure how to pronounce the name of the maker. Is it George Cookie or George Cookie? I'm not an expert in linguistics of the 16th century England. So if you could help me with this, I would be much indebted.
George Cook. Forget Cook. The E, just like Cook.
Oh, okay, perfect.
Somebody who works in a kitchen.
Oh, okay. Then the next thing is I would like to share with you with my admiration of the stereographic projection, which is some may say is only kind of perspective, but for me there is something really mystical in it, that it preserves the angles on the sphere, and that on a very simple piece of metal all the hemisphere can be projected, and this is quite different compared to the standard horizontal or vertical dials with nodus, which cover only a very small part, maybe not small, but limited part of the hemisphere. So there is something really extravagant in stereographic sundials, and this is the reason why I really like them. I think what is also very interesting in this, what was interesting in this specific research is the human aspect of the maker and its relation with his master. It's quite obvious that for newcomers to a business, it's always hard at the beginning to compete with experienced, with those who are already established in the business and are more experienced. But here, normally this is not seen in case of sundials. But here, the research showed that first the brass plate that was used for the construction of the dial was very uneven, of different thickness, and quite which is different than in case of instrument of Elias Allen, who was the master of George Cook. And also previous research by John Davis proved that Elias Allen used different brass with higher concentration of zinc, which had a more which was more golden in look and more valued. So Elias Allen kept the master kept the better looking brass for himself. And this, the third point is that the sundial was made for a location quite far from London, probably for Derby or nearby in Derbyshire, while most of the sundials, stereographic sundials by by the master of George Cook, were made for London. So it is also clear here that Elias Allen hovered the commissions in the local market, and George Cook, as a newcomer, had to accept commissions from distant locations. I think this is very interesting and quite rarely observed in sundial research. And also, I think what was very pleasing for me was the international cooperation during research on this sundial and reconstruction of the gnomon. The metallurgical analysis was conducted by John Davis in England. I did the other part of the research, and the reconstruction of the gnomon was by expert from Germany. So it was international cooperation, and I hope that Torsten Hiller, who conducted the reconstruction of the gnomon, searched for a very specific brass which would match the color of the plate of the sundial and the thickness, which was 4.4 millimeters. And in search of it, he traveled to Dresden, to the Museum of Science, the Mathematische and Physikalische Salon. Unfortunately, he couldn't find a proper brass there, but he told about this research to the director of the museum, and we made contacts together with the director, and there are some plans to make a sundial exposition in Germany as a follow-up of this research. So I think that this is very positive aspect, that there will be some continuation of this research project, possibly in an exhibition. And one more thing, which I think is intriguing and in the future is worth of further studies, is this aspect of making a masterpiece by an apprentice at the end of his apprentice period. Here in the article, one of the suggestions was that the sundial could have been a masterpiece by George Cook at the end of his apprenticeship period. But it's not sure, as sundials normally do not have any specific marks for such an instrument. And I think generally in future it would be, this is the aspect which is worth further researching, the search of the sundial that would be to have any marks suggesting it's the actual masterpiece. So I think these were the major points I wanted to discuss.
Yes, that's splendid. Thank you very much, Maciek. Has anybody got any questions while we have the author with us and willing to answer questions? Are there any hands up, Martins?
Not at the moment. No, I do not see any raised hands.
Well, if you look closely at Fig 4, if you can do that for me, I will make an observation.
Yes,
which Maciek didn't refer to. If you can enlarge the top bit. Right, this is a detail, and where Martins is pointing on the left, you can see 270. And that 270 is the number of degrees clockwise round from due north. So that's due west and represents the setting sun. We'll see in a minute that Elias Allen didn't write 270 there, but here it is at that point. And that, of course, due west is where the sun sets at an equinox. And here we're talking about the vernal equinox, because if you look at the bottom of what you can see now, you can just see February, and then that goes into March, and you'll see just the first two letters of March, M-A. And then that goes around the corner, and we have R-C-H. Now, if we look at the corner carefully, start of March is with a long, broad stroke. And that's actually the end of February, 28th. And then we have 1, 2, 3, 4. There's a little stroke, half stroke for 5, and then it's 6, 7, 8, 9, 10, 11. So, according to George Cook, the vernal equinox takes place on the 11th of March each year. I wonder how many of you noticed that. Of course, at this time, England was still using the Julian calendar, and we haven't had our big 10-day jump at that stage. And so the vernal equinox would typically fall on the 10th or 11th, in this case, 11th of March. At the moment in England, indeed for the rest of this century, the vernal equinox will always be on the 20th of March. But most of last century, it was on the 21st, because we didn't get the correction in the year 2000, which we would normally expect. That was an exception to an exception. If we look down at Elias Allen, well, two things you'll notice. First of all, there is no mark at all where the 270 was. There's a straight line, an unnumbered 0. And the way Elias Allen, and I think William Oughtred, of whom more later, thought in terms of the use of this instrument, was that you could tell how far the sun was setting north or south of due west. And that 10 degrees, which Martin's is indicating now, that's in the winter half of the year. So we're below the equinoctial line. And that would mean that the sun was setting 10 degrees south of due north, due west. And in an extreme case, right down at the bottom, if you scroll right up, so the winter solstice, you can see just about 40 degrees south. So in the UK, and in this latitude, I think, which latitude of Derby, they are getting the sun setting more or less at this time of year about 35 to 40 degrees south of due west. And of course, it can be in high summer 30 to 35 degrees north of due west. If we go back to the equinoctial point, we can see, starting at 28 again, that's 28, that's 1st of February, 2nd, 3rd, 4th, the long stroke for the 5th of March, 5th of March there, then 6, 7, 8, 9, 10. So Elias Allen thinks that the equinox is on the 10th of, the 10th of March, and George Cook on the 11th. Just a little detail, but I wonder how many readers spotted that it wasn't drawn to the reader's attention in the article. Any hands gone up now? No.
Checking.
Yes, checking the participants.
Not really. No.
No.
And,
okay. Well,
checking in chat. Also, no written comments as well.
Right. Okay. Very quiet reception. Well, thank you very much, Matt Check. Let's now turn the page over to the next article, which is an obituary of the late John Lester, who was a very splendid member of the British Sundial Society. And all I'm going to say is that at the bottom of that page, you can see a picture of John Lester with his gavel, which he made for the society. This is used by the chairman at the annual general meeting. And if you can unshare your screen and go into, let's go into speaker mode so that you can actually see. Can you hear me?
Yes.
I can see lots of other people, but I can't see me. Maybe that doesn't.
Yeah, we can see you.
You can see me. Why can't I see? Oh, I know why. Yes, a minute. Right. And I'm now going to hold up his gavel. This is the cradle.
Yes.
Which it rests in, and there it is in place. And now if I lift it up, you can see, if you look carefully, can you see these dovetails?
Yes.
Different people call these different things. I call them secret dovetails. Some people call them hidden. There's nothing hidden or secret about them. They're thoroughly open, but they're very difficult to make, and because they go all the way around in the same sense. A very clever thing to do. Nice bit of carpentry. So that's all I'm going to say about John Lester. And we can now move on to the next article. And this was written by Sue Manston. I've certainly seen her signed in. So, Sue, can you say a few words about this? Tell us about geese.
Yes, can you hear me?
Yes.
Okay. I received a few inquiries about this, or a few questions about this skein dial. The first question was from Frank: how do you pronounce skein? So for anyone who's here, this English isn't their first language, a skein refers to a flock of geese or swans that fly in formation, typically in a V-shaped formation, which you're probably familiar with when geese fly like that. Another query is if anyone has gone to the coordinates mentioned in the references for Google Earth or what 3 words, you will see that the skein dial is actually right next to a piece of woodland, which concerns me rather in that, can we see the figure 1, Martins?
Yes.
That's it. You may be able to see there's the shadow of a tree there in the foreground going across the path. That is looking north, and there's a lot of woodland directly to the southwest of the dial, and I'm slightly concerned that the dial will be in the shade in the afternoon in winter when the sun is lower. So that's one strange thing. The next question was, is the gnomon likely to blow away in these storms we've been having? We think it's pretty heavy, but I'm not sure of the details. We think that the Corten steel is quite thick, and that if you can see figure 3, Martins, you will see what I think are sort of flanges at the bottom of the gnomon. And I think it's probably bolted into the ground or cemented into the ground. So I don't think it's in any danger of blowing away or falling over. But I have contacted someone who was involved with that today and asked them the question, but I haven't got any answers yet. If anyone really wants to know the answer, just let me know and hopefully I can find out. As I've said, we think the gnomon is a fairly thickish piece of steel. And Martins has asked the question that if you look at figure 4, you will see that there is a gap in the center of the gnomon, and at noon that looks like the shadow of sunlight is throwing a strip of light across the dial face. But that gap looks quite narrow, and Martin expressed concern that if that gap is quite narrow, but the thickness of the metal, if the steel is, well, say it's quite thick, then it could obscure the sunlight when you get to a couple of hours either side of noon, say. You won't actually get a strip of light on the dial. So that's another concern. If I do get answers to these questions and anyone wants to know, just drop me an email. Yeah, and the other thing is if anyone gets a chance to visit the dial, it's in Loch Lomond in Scotland, and gets a chance to take some more photos or find out some more about it, then please let me know. That would be really good. I think that's all I wanted to say on that. If there's any questions.
Yeah, thank you very much, Sue. Any hands gone up now?
Not right now.
Not right now.
But really, I also think that it would be worth to revisit the Sundial and explore those questions asked.
We don't have Dennis Coward logged on, do we?
Yeah, I thought maybe it's not really near Dennis, but I thought he might like the trip.
No, it's about 40 miles, which is a very long way if you're in the UK. If you're in the US, that's no distance at all.
No, he's not.
No, he's not there.
No.
Right. Well, we now go on to Dennis's article.
Just a question to the line.
Yes, yeah.
It's Kurt Bill from Austria. I also built several sundials in Upper Austria in Christkirchen. The thin line, could it be explaining exactly what the noon time is, and after noon and before noon, the line disappears because of the thin intersection between these two shades? Could this be a reason to be exactly at noon time available?
Is it a noon mark? Clearly not.
I don't see why it would be, because the dial has, if you look at figures 5 and 6, it has got hour lines marked on it. And my understanding is that the intention is that that line of light should move round the dial and indicate the hour, because the lines are correct for the hours: 1 hour, 2 hour, and 3 hours either side of noon. So I think it's supposed to work, but I have to say that the lady who started this project, I feel it's more of an artistic project to reflect the arrival and departure of the Greenland white-fronted geese, and whereas we are more interested in the engineering side of it, say. And I think Hannah was much more into the aesthetics of it. However, I do feel that the gentleman, I believe, was involved with doing the design and engineering, does know what he's doing. I'm sure he knows what he's doing. And so I suspect that line ought to travel along from hour to hour accurately. But I will ask the question and find out.
In Fig 5 or Fig 6, we're looking north. North is at the top, is that right?
Should be. Yeah.
Yes.
So north is at the top. So when the sun is in the north, when the sun is in the east, it's on the right. And so as the sun goes round, these skeins of geese do appear to move from left to right. Is that how it's supposed to be? So if you did a time-lapse photograph on the ground, you would see them, they would be flying forwards, not backwards. Somebody's got that right.
Sorry, you said when the sun is in the
you've got
east.
A snapshot on Fig 6 shows a snapshot of the shadow at some time of day, probably midday.
Yes, but when the sun is in the east, then the hour markers are on the left.
Eastwards currently. Yeah.
They're flying from west to east, aren't they?
Currently, yes.
Yeah, that's right. Because because as the sun goes round, the shadow goes the other way, and so they are flying in the right direction. So if you took a time lapse, if you took that same photograph, same picture, same drawing, half an hour later, the tops of those V's would be a bit further to the right rather than a bit further to the left. I was just worried about these geese flying backwards, but they're clearly not.
No.
So I think that's quite a nice design, subject to the thickness of the gnomon gap. Well, if no further questions.
There is one asked by Julian. Could Julian ask himself, possibly? Because there's a question about how dove tails are made. But could Julian explain, expand this question a bit? So,
is that how are the holes made in the steel?
Yeah, possibly. Yeah.
Do you know how they're made, Sue?
No.
That's quite a big holes to. Is it a casting or?
No. No, I've got no idea. I mean, I can ask Hannah, but Hannah is currently, let's say, uncontactable for personal reasons. So I've asked questions, but I'm not getting any answers.
No, that's a good question, but we don't know the answer.
Oh, okay.
Right, and the next one keeps us in Scotland. If you can turn over the page. Now we're on Dennis Cowan's article, and in the absence of Dennis, I don't know when anybody's got any comments on this. I should point out that there was a time when Dennis Cowan was deemed, he kept winning the best author of the year competition until he won it so often, but we gave up that competition. But he is very popular with readers. And when he finished his Thomas Ross series a year ago, we were worried that we weren't going to get any more articles. But fortunately, after a year's gap, we've got this article here. And I was particularly taken by the figure 2. So if you can go close in on figure 2. Yes, that's what I want to look at, that shape. And now in an early draft of this article, that was described as a dodecahedron. And I couldn't for the life of me see, it certainly wasn't a regular dodecahedron. And I couldn't count up to 12 sides, or couldn't count up to 6 sides even, until I looked in shadow. And I could convince myself there are indeed 12 sides, but it's not a regular dodecahedron. This is, in fact, for those who know about the semi-regular solids, there are, of course, 5 standard Platonic solids and 15 plus infinity of the semi-regulars. And each figure has a dual. And if you take a cube octahedron, which is sort of halfway between a cube and an octahedron, you find that if you join the centers of the faces, you will get lots of rhombus shapes. And that's exactly what this is. This is the so-called dual figure of a cube octahedron. Study the cube octahedron, look at the dual, and you will see this. I enjoy reading his article. It's very self-contained. Has anybody got any further questions on it or comments to raise? Anyone from Scotland signed in? If not, we look at the Rottingdean sundial. Now, Christine, are you going to say a few words about that? This is just a nice stained glass window. No answer.
Possibly your
It's
mic
in
sound?
a pretty village not far from Brighton, and this church has a large number of really beautiful stained glass windows by Burne-Jones and William Morris. This long picture doesn't really do this one justice. It's quite difficult to photograph, but you can see from the top picture that the colours are really lovely. Whether this is actually King Ahaz himself or King Hezekiah isn't definite, but and although the dial is mentioned in the King James version of the Bible, later ones describe as steps, but you can see at the bottom of the article there's a reference to John Wall's article, which tells you all about everything you could possibly want to know about this.
All these figures can be identified, can't they?
Can't see it.
You've got
yeah, that's all I've got to say.
Yes, that's wonderful. For a short article, there's a lot to say about it. Well, now we come on to this provincial dial that John Davis has taken an interest in. And John's definitely here. Can you tell something about this one, please?
John actually was.
He was here.
He was here, and currently I see that he's not anymore in the call. So
right. Well,
we could
Martin,
hope that he will return back to call.
He may return, and we can backtrack.
Yeah, I will try to spot this moment. Mm-hmm.
Can you go close on Fig 3 and make the point that you made at rehearsal?
Yes. Oh,
it's quite a well-made dial, but not quite well made enough.
So I paid attention to those lines here. That it seems that from one side this dial does not repeat the typical issue with noon gap. It has the noon gap for the thick gnomon, but actually it has another issue. So another issue is related to those lines here. It's at 4 o'clock here and at 8 o'clock here. So they are pointing not to the right edge actually.
Yes,
So,
we call that the back hour problem.
back hour. Oh, okay.
They're called the back hours because they're
Yeah.
up before 6 in the morning and after 6 in the
Yeah.
evening, when everything goes in reverse. And it's a big problem with sundials getting
Yeah.
that right. And a lot of
Yeah.
makers make that mistake.
Yeah. The most common one is noon gap. So, but this is the next one. Yeah, I would say.
Yes, yes.
Okay.
Well, let's now move on to the Mario's article. Now, is Mario with us?
So, I hope so. Where is Mario? Oh, Mario is not here. Although he was in rehearsals.
Right.
Oh, yeah.
Well, can you go to the last page? I think it's the last page where he says that really, no, it's a page before that.
It's
on the right.
It's here, yeah.
Somewhere that's the last page. No, it's the page before. That's page 26, page 25.
Oh, okay.
And on page 25, he says that
yeah.
Italian hours, which we understand to be sunset to the next sunset, arrived in Italy from Bohemia. So really, we should think of them as Bohemian hours because they took precedence. And that's a perfectly valid and interesting point. I don't think anybody's going to stop us calling them Italian hours, but here is an Italian saying maybe they should be called Bohemian hours. And yet, in the first page of his article, if we go to that, down on the bottom right, if you can enlarge on that, he said, no, on the left, bottom left, I think he says that in Athens, they used the hours from sunset to, yes, Athenians a bit lower, natural few lines lower. Yes, Athenians sunset to sunset, Babylonians sunrise to sunrise. And that's early in his article, and that's the first mention of a sunset to sunset scheme. And if that was being used in ancient Athens, maybe we should call it Athenian time, long before the Bohemians. So that's a historical point about which I have no knowledge to back up one way or the other. So for an expert present, please tell us. Otherwise, in the absence of Mario, I think we're stuck for further ideas. The Italian hours are, of course, if you go to Italy, you will find many, many examples. I won't say they're still in use, but there is certainly evidence that Italian hours were in use in Naples right up until the 1860s. And you can tell that by the times on theatre programmes, which would start at 1 o'clock in the evening, meaning an hour after sunset.
I think we also asked whether nowadays Italian hours are being used, and it seems that currently more popular are so-called reverse Italian hours, or time to sunset.
Yes.
Hours.
Yes, some people call those H2S or H2SS, hours to sunset. Of course, it makes no difference, really. They're the same line, it's just a labeling question. And are we counting down or are we counting up? And well, take your pick.
Okay, as there is a question asked by Julian. Sunset hours, how are the hours of darkness marked?
Right, well, I can answer that on a typical sundial, they're not marked, but they do count from naught. Well, sunset is essentially 0 or 24, and then the hours of the night are 1, 2, 3, 4, 5, and so on. So typically, at an average time of year, 6 Italian hour is midnight, but of course it may be before or after that, depending on how things are going. And when you get to midday, you've got another 12 hours on. And so midday at an equinox is 18 hours, and midnight is 6 hours. But that's only at an equinox. And you can look at the lines. Yes, there's a typical one.
Can I come in and speak or not?
Yes, of course.
Yes, please.
But if you start at sunset,
yes,
and you've got prayers, you're in a monastery and you've got prayers through the night, how are the hours actually counted? How do they know when it's midnight or 3 in the morning or whatever?
All right, so that's totally independent of what time system you're using. How do you know how far you are through the night? Right, okay, I can tell you all about prayers. There is, of course, the sunset prayer, which is Vespers. And so that's obvious, you wait till the sunset. And then the next prayer is Compline, which is when it's just getting very dark, too dark to see. And there are different definitions of that, depending which religion you're using. In the Bible, the Christians say it's getting dark when it's bedtime, on retiring. Well, what on earth does that mean? That seems to me the most useless definition of when to say that prayer that there can possibly be. The Muslims, as you will know very well, Julian, deem that the equivalent time, the Fajr prayer. So, I mean, the Isha prayer. We've just had a storm, incidentally, called Isha, and I cannot understand why we have a storm named after Islamic prayer time, but there it is. No, Asr's afternoon. Isha is for one which is when the sun is 19 degrees below the horizon. Now, the Muslims have a much better definition. Their definition of total darkness is when you dangle a piece of white cotton at arm's length and you just can't see it. That's time to say the Isha prayer. So that's how they would know. And the Jewish, on the other hand, have yet another definition of their equivalent prayer when it's getting very dark, which is when you can't recognize the face of somebody at 6 feet apart. So roughly 2 meters. So if you can't see your friend who's in the same room, then it's time to say the equivalent of the Compline prayer. So that's how they did it. There were other ways of doing it. You would have a cantor who would just knows what rhythm he was singing psalms to, and he would go on singing the same psalm hundreds of times or as many times as necessary to get the elapsed time, and they could be pretty close to that. But of course, they did have clocks by the 13th, 14th century, and that's all mentioned in the article. So by that time, you could use the clocks with Virgin Folio escapements during the night to tell you when to say the prayers.
But we do have a problem in the Northern Hemisphere where darkness is at quite different times, summer and winter.
Yes, absolutely. And what's worse, if you're a Muslim in our latitude, the sun never goes down to 18 degrees below the horizon in the summer, so you're a bit stuck. So they have relaxed rules about this kind of thing.
I think we can disregard the Muslims for this point, can't we? But it is the Christian church which required to sing different services throughout the night, and I was wondering how how it worked.
Well, according to my reading of the Roman Catholic canon, it is not singing. Maybe in a monastery you would sing all the way through the night, but the set times was only Vespers, Compline, then midnight, which was wasn't really midnight. It was
what time do you close?
Beg pardon?
I think I'll come tomorrow morning if you don't mind.
Ah, right.
Yeah.
What time do you open in the morning?
Yeah.
So Martin, can we go on?
I will mute. So sorry.
Can we go on to the next one, which is another Sue Manston article, and we know we've got Sue here, so you can tell us what's going on with this one.
Okay. The help and advice line service was contacted by a lady called Annie Wright, who'd bought this sundial at a very large antiques market in Leicester called Freeman's Common Antique Centre, where there's apparently about 100 vendors selling antiques. It's huge. She bought it. She was told it was a vertical wall dial, and she contacted us because she wanted to know how it worked. I had a look at this for a while and thought, this isn't a vertical dial, this is an equatorial dial. And for some reason, it's set in a wooden base, very nice wooden base, and it is oriented in the vertical. So it looks like something that was made for example, display in a shop window or something. We're not really sure. She bought it because she recognized the name John Whitehurst, who was basically a clockmaker of Derby and also sundial maker. He apparently had a very large business with lots of apprentices. And this may be an apprentice piece, for example. Okay. If you look at figures 5, 6, and 7, thanks, Martins, you can see on figure 5, you can see a little line with a solstice zodiac sign for Cancer. And on the figure next to it, it's got the sign for Capricorn. This is quite an unusual feature because, as in the next figure, Martins, just a bit further down, you will see that in summer and in winter at the solstices, just around noon, the shadow of the dial plate will actually fall on those lines on the gnomon, showing when the sun is at the summer solstice or the winter solstice. So that's something I've only seen on one other dial. So I thought that was quite unusual. Right. Figure 8, please, Martin, on the next page. Martins, yeah. If you can.
Yes. Sure.
Next page, figure 8. Yeah, that's it. If you can zoom on that one, make that larger. Right. You may be able to see there's a set of dots on the number 1. There's also a set of dots on number 4 and number 5. The reason for that is we can see those numbers were originally, let me do this, 12, 11, 10, 9, 8. So whereas 4 was originally going to be 8, it looks like that started with a V. No, the next one down, Martin. If you move, that's it, the 4. Yeah, you can see the row of dots underneath. It was originally a V111. The engraver must have forgotten that on the underneath, this is the winter side, on the underneath of an equatorial dial, the numerals should go anti-clockwise, not clockwise. So they've been put on wrong, and then there's a series of dots where it looks he's tried to sort of hammer out the mistakes. So that was maybe one of the reasons why I say, excuse me, I say it was a practice piece, or why it was mounted like that just to show in a shop window. Who knows? But perhaps that's why it wasn't put up for sale as a working dial. Right. Frank and John and Christine might shoot me for this, but I have noticed an error on page 28. Could you go back?
No, next page.
To 28. No?
Yeah.
Or which one?
That's the first page of the article.
Yeah, it is. Yeah.
Right.
Second paragraph.
Second paragraph.
If you can enlarge that a bit. There you go. Where it says the dial is shown in Fig 1 in the second paragraph, the dial plate is a circular disc, probably brass. It's not 95 millimeters, which is a bit small at about 4 inches. It should actually be 195 millimeters. So it's more like 8 inches diameter. And I think I must have, well, I missed that in the proofreading, so I apologize for that. The reason I mention that is that now Annie has realized that this isn't a vertical wall dial like she thought. She's decided she doesn't want to keep it. She wants to sell it. So if anyone would be interested in talking to Annie about purchasing it, just drop me a line, send me an email, and I'll put you in contact with her. That's about it, unless there's any questions.
Oh, I think that's lovely. Yes, well, lovely explanation. I have to say it's not my favorite Sundial, but I thought it was a very, very good exposition. I'm not quite sure I'd even noticed those funny marks on the gnomon, but that's a very convincing explanation. Right.
Yeah, is there no comments and questions? Yeah.
I think we skip the bulletin follow-up and look at page 32. Is Ben Jones here? He is. Yes,
Yeah,
Ben, can you say anything about this? Or has he gone to sleep?
There is Ben. Ben, your microphone is muted. Please unmute, as you are on call. Unfortunately, no.
No, he's not coming in. Well, it's a fairly self-contained article. There are undoubtedly, if you wander around churches in the UK, medieval churches, you find all sorts of scratchings. And they have become very much a subject of interest for enthusiasts. And some of these scratchings have nothing to do with sundials. Others very much do have something to do with sundials. And this article just gives us a rough survey of the sort of things that you might find if you go to the right sort of church. Lots and lots of scratches which can be interpreted in different ways.
Ben
sent
a message that there is
yeah,
problem
Ben
with
Jones
microphone.
sent a message.
And what's he say?
I cannot get my mic to work. So unfortunately, technical problem.
Well, he can hear us, so can we suggest that he points to the microphone in the bottom left-hand corner and clicks on it? It might say mute.
Yes, in the menu there is this icon of a microphone, or another option if you are using it on a computer, you can just press spacebar. That also could unmute it for that moment. Okay. It seems no, sorry, none of
that.
None of it seems to be working. Okay. Yeah. Unfortunately, yeah, we should continue without the comments by author of this article.
So, right, well, now in the absence of comments, let's go to page 44, where we have the final item of interest. That's that postcard at the bottom. Peter Ransom article. Christine, going to say anything about this? No? It's an interesting place. The Sundial itself is not particularly exciting, but it's got a good backstory to it. That takes us to the end of the bulletin. I suppose you might just show the back cover for completeness.
Yeah. I would like to invite you to fill a small survey.
Yes.
I posted the link, but there's just one answer so far. So posting once again. I hope you get it. So yeah, there are just two questions about your reading habits.
So go to the chat list. Point to the chat icon. Open it. And you'll see a long URL beginning HTTPS. And if you click on that, you come to a survey. This is a voluntary survey. It will be completely anonymous. We won't know who it is, just so that you can state some views.
Okay, and so we can continue with the next.
Next item on the agenda, we come to the postscript. So if you stop sharing and I start sharing.
Yes.
There. Right. It comes from postscript, and here I discuss double horizontal sundials. I have been inspired by Matchek, I've been inspired by the George Cook sundial, and I've been inspired by Sue Manston, as we shall see. And so I have things to say about the double horizontal sundial. And if you really want to know everything there is to know about double horizontal sundials, you should acquire the BSS Monograph 5, which is a collection of articles and descriptions by John Davis and Michael Lowndes 15 years ago now. It's a really splendid work of reference, and one might at first sight think this is not really appropriate for beginners, but bundled in this collection, there is a kind of beginner's guide written by none other than William Oughtred himself. And William Oughtred is generally regarded as the inventor of a double horizontal sundial, at least in England. And he wrote a very accessible user guide for people who bought his sundials from the maker, Elias Allen, referred to in the lead article. And here is my best attempt at a reproduction of the title page of his article, the description and use of a double horizontal dial. Well, slightly strange spelling, but it's very understandable. And this really is a user guide, whereby not only the hour of a day is shown, but also the meridian line is found. Well, not too surprising that you can tell the time, the hour of a day on a sundial. That being able to tell the meridian line might be thought to be quite an achievement, but he then goes on to make the claim that, and most astronomical questions which may be done by the globe are resolved. Well, I'm going to show you some astronomical questions which can be resolved by this sundial, which perhaps even William Oughtred didn't think about. For completeness, I should say that William Oughtred's user guide was actually transcribed by Fred Sawyer, who's listening in. And so I'm very grateful both to Fred and to William Oughtred for providing me with his nice introduction to double horizontal sundials, and I commend it to you. So let's go to a blank screen. And I have a message, two messages in what I'm going to say today. They're both sort of personal observations, but I'm going to talk about them nonetheless. The first is that if you see something you like, in particular a sundial, anything you can look at that you like, then I strongly recommend sketching it. You don't have to have good draftsmanship skills, just rough drawing will do. But there are 2 points about making a sketch. The first is that the very act of sketching something means your eye is drawn to attention to various details that you otherwise might not have missed. Like, do you remember in the lead article, George Cook thought that the equinox was on the 11th of March, Elias Allen on the 10th. That's the sort of thing you notice when you try making sketches. There is something even more important, but when you're sketching a design, somebody else's design, you can think of ways of customizing it, tailoring it to your own requirements. You can add your own artistic creativity and so on. And you may even spot things which are actually unsound about the thing you're looking at and think of improvements. And I'm going to illustrate all that by drawing a sketch of the George Cook dial plate for my latitude, 52 degrees north, just a little bit south of Derby. And you start straightforwardly enough with a circle drawn round the center. I'm not asking for anything terribly ambitious, but immediately we see, wait a minute, that black spot I've drawn in the middle isn't going to be very helpful, because if I want to represent the foot of the gnomon, that's where the gnomon meets the dial plate. If you look at the photograph, you see we actually have a long, thin rectangle with a sharp point like this. So I replace my spot with a footprint. But again, pretty rough, but there it is. And here I declare my lack of enthusiasm for this kind of gnomon. The vertical gnomon is called a knife-edge gnomon. It's a very sharp edge. That's the tip of this triangle. And it doesn't get the shadow right all through the daylight hours. let's mark in a typical shadow. The sun is roughly southeast, bottom right, and the shadow runs off the edge of the rim. That's fine. And we've got two very clear straight edges, one coming from the left-hand edge of the long, thin, polar-oriented gnomon, and the other shadow comes off the vertical sharp edge in the footprint of this. You can see that's the apex of this triangle. And no problem so far. That's all perfectly reasonable. There are no markings yet, but you can imagine reading from either of those edges to make two different kinds of observation. But there comes a moment in the morning when the right-hand edge exactly aligns with the right-hand side of the triangular tip. That too is not a problem. But from then until the equivalent time in the afternoon, so that's an hour or perhaps more, either side of midday, then you can see that the shadow doesn't run from the tip, it runs from the bottom right-hand corner, bottom right-hand vertex of the triangular tip. And so that shadow is displaced to the right from where it should be. And unless you take that correction into account, your observations are going to be biased too far to the right. And I regard this as unsound design that really shouldn't, inexcusable to have an instrument which is wrong, particularly wrong at midday, which is perhaps the most important time of day for sundials. But that's not the only grumble I have about this gnomon. The long tail of the polar-oriented element is very prone to break. It certainly bends easily, it's very fragile, and that's another bit of just poor engineering. It's mathematically sound, but the engineering is unrobust. And finally, the way things are constructed, the vertical gnomon is tucked under the polar gnomon and thereby has its height limited. Still no problems at 52 degrees north, but if we head southwards, where of course the gnomon becomes less and less steep as you head towards the tropics, then that means that the gnomon is going to be shorter and shorter and shorter. Exactly what you don't want, because around midday, the further south we are, the higher the sun, and so the shorter the shadow around the middle of the day with a vertical gnomon. You actually, if anything, want your vertical gnomon to get longer around midday rather than shorter. So I don't like this design, and I'm going to throw it away. This is where I customized my own requirements and go back to my little black spot and deem that to be a circular hole drilled into the through the center of the dial plate and into whatever is underneath, a block of wood or a block of stone, whatever. And then you simply insert a vertical rod. I think in terms of a knitting needle, because I have lots of knitting needles of varying lengths and thicknesses, and if you put a knitting needle in there, perhaps a very short one, typical shadow will look like this. And of course, the shadow is now a line shadow, and the width of the line exactly matches the diameter of the rod, the vertical rod, at all times of day, because this is a vertical rod. And all this can really directly tell you is the direction of the sun. Remember, the gnomon is vertical. But of course, with a short enough gnomon, we can deem the tip to be a nodus, nothing to do with a stereographic direction, but the end of the shadow will indicate a position. And we can mark that with a counter. And we can repeat at intervals during the day. So a bit later, put down another counter, and another counter. Now, although this is nothing to do with a stereographic projection, I am doing this because Uhtred himself talks about tracks. You track the sun along a track. I would use the word path, or in this case, we're obviously going to get a constant declination line, but I rather like his term tracks. And of course, we can join the dots. And what I've actually drawn you is a perfectly ordinary mnemonic projection of the track of the sun, or track of the counter at the summer solstice at my latitude, 52 degrees north. And we all know that you get a straight line at an equinox, and you get a hyperbolic arc going the other way at the winter solstice. So this is a very embryonic mnemonic projection. And these tracks from a vertical pillar of some sort were known to the ancients, literally thousands of years ago, and represent one way of knowing how far you are through the year, from summer to winter and back from winter back to summer again. So chopping up the year, you can put in as many intermediate tracks as you like for relevant parts of the year, when you should sow crops or harvest crops and whatever. But chopping up the day, well, there are many, many different ways of doing that. And to cut a long story short, I'm just going to divide the day up into common hours. That's 60-minute intervals from the vertical line in the middle, which is the midday line, which is when the sun is on your local meridian. Now, as it happens, I live within walking distance of the Greenwich meridian, so I'm going to treat this as though it were the Greenwich meridian, pretty close to where I live. I live close to the Greenwich meridian, but I do actually to 52 degrees north, which is the assumption being made here. I can mark in some numbers, and we all know how to use this sort of sundial. If I go back to that original shadow, we can now see that this is not just the summer solstice, but it is 6 o'clock in the morning of the summer solstice. Now, people use sundials in different ways, and they're often used for commemorative purposes. And let's just suppose that you were born on the day of the summer solstice, and it happens that you were born at 6 o'clock in the morning. Well, somebody must have been. And so this to you is a very important moment of the year. Oh, wait a minute, before we go back, I'm going to address Uhtred's question of finding the meridian. You can do that. Suppose you go to a friend and you haven't got the true north direction, and you just put this down at an arbitrary angle. When you just swivel it, knowing it's the day of the summer solstice, you just swivel the sundial until the shadow is on the tip of the shadow is on the summer solstice line. So I'd obviously rotate this sundial to the left. The shadow, of course, stays pointing the way it has to point. I've overdone it, and now I come back right. Well, now I'm going to continue the pretense of being born at 6 o'clock in the morning on the day of the summer solstice and put down a red spot, a red letter day for somebody with a birthday at this time of day on the summer solstice. Now, sun goes in and we go through the year. All through the year, whenever you go out, you can see that little spot reminding you of your birthday and time. But that doesn't just mark a time of day, because when the sun on a summer solstice is indicating that particular point, the sun itself is directly overhead on the Tropic of Cancer and is 6 hours, 6 hours before midday where I am. So that's 6 days in my case before the Greenwich meridian. So that will be, wherever this place is 6 hours ahead of the Greenwich meridian. That's 90 degrees east, and 90 degrees east on the Tropic of Cancer is somewhere in Bangladesh. In short, these constant declination lines and these hour lines directly correspond to geographic lines of latitude and longitude. 6 hours later, the sun is on the Greenwich meridian, and it's directly overhead on the Greenwich meridian, of course, at 0 degrees east and 23.44 degrees north, and that's somewhere in Algeria. And for completeness, I'm going to put two more suns down on the equator, and that just happens to mark the east and west coasts of Africa, where the equator crosses Africa, east coast and west coast. And you could continue pairs of lines like that and get a map of Africa. You will notice a little spot here that corresponds to the North Pole that lines with the 6-6 line, and the big black spot is me, my local position, 52 degrees north, Greenwich meridian. Some catastrophe will never shine on that point, but it nonetheless has geographic significance. And this, of course, is a mnemonic projection, which I put to one side. That's by way of introduction. And now I want to show you the exact equivalent diagram for the stereographic projection. Again, I have three Constant declination lines, just a different shape. They're all arcs of circles. No longer a straight line for the equinox, and yet another circle for the winter solstice. And it's just a different form of projection. Yet another form of projection, better known to most people, is the Mercator's projection, which shows lines of latitude and lines of longitude as parallel lines. You just get different distortions depending on your choice of projection. And as Merchant noted, you do much better with a stereographic projection because the mnemonic projection has its limitations. Look, here is the equinox, and we all know on the day of an equinox, the sun rises at 6 o'clock. But this line isn't starting until 7 o'clock, and it finishes at 5 o'clock. We're losing an hour at the beginning and the end of each day. Of course, you could make that circle bigger, but it gets bigger and bigger, and the horizon, unfortunately, is at infinity. So you're never going to win. And likewise, we know that in British latitudes, at the summer solstice, the sun rises about 4 o'clock in the morning, just before 4 where I live. And yet here we're seeing just before 5 o'clock. So you're losing at the edges. This outside circle on a mnemonic projection has no great significance. But on the stereographic projection, it really represents the horizon. Moreover, not only can you get everything within your local horizon on the stereographic projection, but there's nothing to stop you going beyond it and seeing what's on the other side of the horizon. We'll come to that later. Now, the next thing I show you is reminding you of the front cover. And I see lots and lots of lines on his diagram. So just to show I can put in lots of declination lines too. I tend, for description purposes, to dislike having lots of too much clutter in a diagram. But whereas Mr. Cook and indeed Elias Allen both had declination lines at 2 degrees intervals, I'm sticking to 5 degree intervals. So this is the equator, 5, 10, 15, 20, and of course 22.4, well, 22.5 in Cook's day was what was treated for the equinoxes, and negative ones for going towards the winter solstice. And I've marked in some hour lines too. And notice both the hour lines and the declination lines are all arcs of circles. The only thing you can see which is not a circle is the midday line, which is a circle of infinite radius. Now, we need to know how to use this, and here I use Mr. William Uhtred's guide. He says, well, you need to make use of the mnemonic projection, your polar sundial. That's why it's a double sundial. And I haven't said anything about the gnomon here. I'm going to use a vertical gnomon as I've described. And you can see a little elliptical hole there because I'm drilling in at an angle 52 degrees to the horizontal. And so I can use the same rod in both places. And that saves me getting 2 shadows, which is slightly confusing. So that's my own interpretation of how to set up one of these. Another great advantage of using these little rods, it doesn't matter if they break or disappear. They're quickly replaceable at very low cost compared with making a new double gnomon in the Elias Allen style. So what Uhtred says is you look at the shadow from the polar gnomon and note the time of day on the outer chapter ring. Well, that says it's 9 o'clock. And the shadow goes across the stereographic projection, but you've got to train yourself to ignore that bit and just look at it, the number in the outer chapter ring. 9 o'clock is the time of day. So what Uhtred says is you now mentally highlight the 9 o'clock hour line on the stereographic projection. And in my view, I have this magic property on my design. I can switch on highlights like this. So that's highlighting the 9 o'clock hour line as Uhtred described. And from then onwards, for the rest of that day, you're not going to need this gnomon, but I'm going to keep it in position just for a little bit longer. And now put a second gnomon into the hole, which is vertical. And what Uhtred says is you note where that intersects the 9 o'clock hour line. And that's clearly on this heavy declination line, which is minus 10 degrees. So we're in the winter half of the year. And what Uhtred says is you then the rest of the day, concentrate on that particular line. And that is what Uhtred calls the track of the sun for this particular day. So I've removed the first gnomon, that's no longer relevant, and I can remove the highlighting on the 9 o'clock line, and Uhtred talks about tracking the sun for 10 o'clock, 11 o'clock and 12 o'clock along its track for the day that you have settled on, that has been indicated for you by the procedure which I just discussed. Well, you can do that. That's pretty much all there is to be using it in a simple-minded way. And at this point, I am going to add these two dotted lines. And what we saw in the article was this corner, which is the sunset at the solstice, at an equinox. Well, these two lines, dotted lines, are what Uhtred calls ecliptic arches. In the 17th century, the word arch and the word arc were pretty much synonymous. And again, this shows my own particular idiosyncrasies. I really don't like these lines. I particularly don't like the way, sort of coming down this one, this is December, sort of January, February, March, April, and then we go May, June, July, August. This is not how the ecliptic works at all. The sun doesn't suddenly go backwards. Moreover, the ecliptic, like the sun, moves. These are not really properly ecliptic arcs at all. I would much prefer them either to be called snapshots of the ecliptic. It's most unlikely that Uhtred or Cook would have said snapshot, because snapshots weren't invented in those days, but they could describe these as showing two sidereal times. Now, this one at the bottom is showing sidereal hour 6, and this one is showing sidereal hour 18. But I want to convince you that there's a better way of doing this. So I'm going to get rid of those. And moreover, I'm going to use my own artistic endeavor and to say I much prefer having the 7 standard declination lines on my stereographic projections than 22-degree intervals. Of course, Uhtred was using those lines for telling the date. Well, I would have the dates in the margin or declinations in the margin. And some people who've made modern double horizontal sundials have done that. This, of course, is showing you the lines at 30 degrees of solar longitude intervals. So this is first point in Aries, Taurus, Gemini, and Cancer, and so on. Right. Well, now let's see what we can do with this. Suppose one day you get up in the morning, go out with your 2 gnomons, and you see these 2 shadows. They're both parallel. And, well, let's follow Uhtred. That says 6 o'clock in the morning. And so we identify the 6 o'clock hour line, and we find the shadow is right at one end of that 6 o'clock hour line. So we're identifying the equator. So this is the day of an equinox. It's not telling you which equinox. That doesn't matter too much. I'm going to suppose that it is the spring equinox. These days in England, that begins on the 20th of March. Right, now I'm going to mark that point with a little counter. Uhtred doesn't talk about counters, but he does talk about following tracks. So I'm going to put a little counter there. And then I'm going to do this for 7, 8, 9, 10, 11, 12 o'clock. And cutting a long story short, have a sequence of counters like that. And at 12 o'clock, of course, both these shadows align. No need for a gnomon gap. You're measuring from the center, making your observation from the center of these shadows. Right, at this point, I suddenly had an inspiration. I thought, wait a minute. Uhtred is talking about tracks. Look, 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 look. We know that an astrolabe is a sort of clockwork, not an astrolabe, an astronomical clock. And there are still quite a few astronomical clocks, medieval ones in England, good one at Hampton Court, but of course a good one in Prague, where they're all over the place. And these are essentially mechanical astrolabes, where instead of having shadows, clockwork drags the sun around and you indicate the time of day. It's as though you've got an animated astrolabe. And I thought, well, why not have an animated double horizontal sundial? So I'm going to introduce my clockwork sundial. And I'm picking up the story after the sun has traveled along this little railway line and got to there at midday on the day of an equinox. I'm going to suppose this is a very, very special equinox. It just happens that the sun is exactly crossing the equator on the Greenwich meridian at midday on this instance of the equinox. So that's 12 noon on an equinox. And noting that astronomical clocks tend to have an ecliptic ring as astrolabes do, there's no reason why I shouldn't mark in an ecliptic, provided when the sun moves, I drag the ecliptic round with me. That's what astronomical clocks do. That's what astrolabes do. Well, that's what my double horizontal sundial is going to do. Now, I can ornament this in various ways. My first idea was to put a little blob. Can you see little green blobs at 30 degrees of right ascension from the sun, like that and that? And that exactly coincides with the crossing of the 7 declination lines. So they're really not needed. If you forget where that green dot was, well, just remember where it crossed this red line. So I'm going to cut those out and instead leave just one green dot. And can you see all these little white dots? They correspond to Utreds and Cooks days of the year. And you probably won't be able to see, but if you've got a good resolution screen about here, which is 20 days or 19 days before the 20th of March. So that's the 1st of March. And you'll see the gap between the 1st of March and the 28th of February is about 1¼ widths of a day. I've taken into account the leap year, which is more than Uhtred and Cook and Elias Allen did. Right, what happens next? Well, I could wind up my clockwork and it's going to drag the sun along approximately along the equinoctial line, dragging the ecliptic with it, and 3 hours later, and this is 3 sidereal hours later, that green spot, which is the first point in Aries, is on the 3 o'clock hour line. But the sun, you need very good eyesight for this. The sun is exactly straddling the blue line, but it is not quite up to straddling the black line, because in just 3 hours, the sun has moved a tiny little bit along the ecliptic. Roughly speaking, 10 seconds an hour. So this is about 30 seconds into that hour. Let's go on another 3 hours, and this is 6 sidereal hours after midday, and the sun has dropped down behind another 30 seconds. So this is about 1 minute, 1/60th of a way back to the 5 o'clock time. Well, what happens next? Well, sun has reached the horizon, so we're going to get sunset. The things we're going to have within my horizon, it's going to go dark. So my clockwork sundial can do all that. Look, it's gone dark and the stars have come out. Well, some stars anyway. Can you see Orion here? That's Orion's belt. And you can follow belt down. You can see that great fat one. And that, of course, is Sirius. You'll recognize Betelgeuse there. Now, Orion is upside down, but it is the right way up. You'll probably know that Sirius is to the east, and the northern hemisphere to the east of Orion. And there you see it. Well, of course, what Matchett didn't say is that not only is the stereographic projection allowing you to see right up to the horizon, but it allows you to see beyond the horizon. So let's see what's going on beyond the horizon, where, of course, it is now daylight. And here I've shrunk my local horizon to this much, and you can see all these red lines. They're all complete circles, the lines of constant declination, and you can see the whole of the ecliptic. And there it is with the sun now just a little bit off center. The sun head is just moved on to the left, to the east of the first point in Aries. And now, well, it's nighttime, and so it stays dark within my horizon. Let's move on to 180 degrees. This is now exactly 12 hours sidereal time. And you can definitely see the sun is not spot on there, although the green dot is. Let's move on another 6 hours. And now we're coming to sunrise. So all this is sort of going into reverse. Can you just see the sun is at sunrise there? That's 18 sidereal hours. And of course, it's not quite sunrise because the sun is still just a little bit below the horizon. I go back to my close-up view. There you can see the sun just showing itself, and it's definitely a bit before the 6 o'clock line. And now here we are, exactly 24 sidereal hours after the starting point. And do you see that the sun is definitely to the left of the 12 o'clock hour line? In 24 sidereal hours, the sun loses about 4 minutes. So we're definitely moving along that line. Oh, and in my diagram, you can see, but not so well, of course, because it's no longer dark, I have a representation of Orion. Orion's coming on, but not fully up yet. And not that you'll be able to see it because it's broad daylight. After all, it's pretty much middle of the day. So bright sunlight, we wouldn't actually see any of those stars except with special equipment. Let's move on here. Now, I've moved on about 3.5 hours after 0 hours. This is 0 hours sidereal hours. This is 1, 2. So 2.5 sidereal hours after the meridian. And the reason I've done that much is that it just lets Sirius rise. Now, Uhtred talks about astronomical questions. And a very important question to the ancients was the time of the heliacal rising of Sirius. They wanted to know when you could see Sirius rising above the horizon. Clearly, at the time of year that I am showing here, that's impossible. Because at the time Sirius is rising, sun is still shining brightly, it's early afternoon, and there's no chance whatever of seeing Sirius rising. That's not going to happen for quite some time. So this is a nice thing. Just like on an astrolabe, you can move the ecliptic around and you can move the sun along the ecliptic using the rule. Well, you can do the same thing on my clockwork double horizontal sundial. I'm going to freeze the sidereal time of day, but move the sun 60 degrees, a lot of solar longitude. So it is now on the first point of Gemini, and you can see it's on that red line, not quite at the summer solstice. You can still see the green dot. That's the first point in Aries. So Aries, Taurus, Gemini. Here's we're at touching point for Cancer, and I'm now going to move it on to Leo, and here's the first point in Leo, and we're almost a whole star away from it just rising. Now I'm going to pause there because we've now set up my clockwork double horizontal sundial to show sidereal time when Sirius rises, and that rises at this sidereal time every day at my latitude. So it's not going to be much help to the ancient Egyptians, but never mind, it's helpful to me. And we're still not seeing it because there are times when you can see Sirius in daylight, but you probably wouldn't quite see it, certainly not at my latitude when the sun was that much risen. So let's nudge the sun just a little bit further along the ecliptic so it is below the horizon. Oh, and it's gone dark, of course. And now, at last, because the sun is below the horizon and Sirius is just above the horizon, this marks the time of year when we just start to see Sirius rising after a long summer period when we saw Sirius often enough, every day perhaps, but we didn't see it actually in the act of rising, and now we can. And then here we are with the sun more fully risen, and then Sirius will go out. So you see, I can solve astronomical problems with this variant of the double horizontal sundial. Now, I go back to the default state, and that's to say, if I were going to have these funny dotted lines, I would probably settle for just one and say this is sidereal hour 0, and engrave this on the dial. As it is, of course, I can move it. But I take that as the reference point because this is the start of a sidereal day, every day. And let's have a look at that in the round. So we've now got nighttime on the outside below the horizon, and it's daytime where we are above the horizon. And this is still latitude 52. Things become more interesting if we move to the tropics. We're now at latitude 23.44 these days. And so we're on the Tropic of Cancer. And so this black spot is on the Tropic of Cancer. And this is the Tropic, I don't mean that. Yes, I do. And this is the Tropic of Capricorn, which is now a straight line. So those of you who understand the simple geometry, I give you this as a challenge, really elegant, trivial proof. But when we are at the standing on the Tropic of Cancer, then this projection causes the Tropic of Capricorn to be a straight line. And I should say that when you're implementing this on a computer, it's only the nadir directly underneath you that cannot be projected on a stereographic projection. And of course, that goes off to infinity. And it's amazing how often when I was setting up these diagrams, I hit infinity and got arithmetic overflow. That's a trivial detail. Here we are on the equator. And notice what a splendid shape we have for the ecliptic. It's a straight line. And it's tangential, of course, to both the Tropic of Cancer and the Tropic of Capricorn. I'm going to backtrack. We're now at 6 degrees north. And at 6 degrees north, I'm going to enlarge this and put in a shadow. And can you see why these double horizontal sundials, like Mr. Cook's sundial, are essentially useless instruments in the tropics? So we come out on the day when we're at on the first point of Taurus. So this is the 20th or so of April. And so a month after the equinox. And we see the line here. What time is it indicating? Can't tell. Could be 7 o'clock, could be 9 o'clock. And if you had paid close attention to the previous bulletin follow-up, you will have seen me show you that in the tropics, the sun doesn't go round monotonically around the horizon. So it would first appear here, a bit further south than it is at the moment. And then as we go along this line, it goes a bit further north, peaks here, and then goes, further north, getting muddled. And of course, at midday, it is to the shadow is to the south. The sun is in the north during most of the day, if we're this side of an equinox. So double horizontal sundials are not useful instruments in the tropics because they are essentially azimuth dials. Azimuth dials are much better than altitude dials in temperate latitudes, where I live, because even the depths of winter, winter solstice, the sun goes round about 100 degrees round the horizon. And whereas in the tropics here, it's staying much the same until midday, then it suddenly flips. Well, I go back to this position, and I think that's probably time for me to stop. Anybody got any questions? What fun you can have when you design your own double horizontal sundial. Is anybody still with us?
Yes, there are participants in this call.
So Maciek, what do you think of this sundial? It's not quite like it good as yours, but it's fun, isn't it?
Can you hear me?
Yes.
Yes.
Very nice. I like it very much. Actually, the form of the ecliptic arcs on the double horizontal, the classical, are quite confusing. But this is probably to the fact that there was not enough space on brass to draw what you have drawn. I would only add that the height of the vertical gnomon for the vertical for the horizontal stereographic sundial is half the radius of the dial, irrespective irrespective of the latitude of the sundial.
That's true. But if you're at the equator, your polar gnomon is flat on the dial. How would you arrange your polar gnomon on the equator?
Yeah.
You see the problem. These are impractical instruments when you get to the tropics.
Yeah.
That's the problem. What you say about the radius is exactly right. I think that my main problem with these dotted lines is that, I mean, I always like to think, suppose I'm explaining something to somebody who's never seen a sundial of any sort before, and you want to introduce the ecliptic. This is a very bad way of introducing the ecliptic. This is a much more, to me, this is one ecliptic line which moves around is a much easier way for people to understand the ecliptic than having these two ecliptic arches. But I do understand your point about the constraints of being in the 17th century.
Mm-hmm.
So I see Fred looking at the screen. Are you going to have a comment?
Can I make a comment?
Yes, sure.
John Davis did an article on a double horizontal he made for a gentleman in the US, which was obviously at a lower latitude.
Yes.
And he does discuss, I can't remember the article, I don't know, I can look it up, and if anyone wants to know, send me an email. I can look it up. He discusses about the height of the knife edge vertical polar gnomon, the knife edge gnomon, and he does discuss, and he changed the position of the gnomon to account for that, but he does go into some detail about it. Sorry, I can't remember the actual article, but I can look it up.
I mean, what Matchett says quite right is about the radius, matching the radius of the horizon circle. There's nothing to stop you moving. Well, you could in principle move the root of the gnomon right to the edge of the dial plate. But you can't.
I think he moved it forward because it left him a lot of space behind the gnomon at the south end, and he put in something else to fill that space. I can't remember what it was.
So
I don't think his knife edge was half the radius of the dial.
I think that in the monograph of on double horizontals, there are some two dials by Malcolm
Barnfield.
Yeah, from South Africa, and they were also they had also moved the starting point of this polar gnomon almost to the edge of the dial, as far as I remember.
Yes, and there are lots of ways of overcoming the problems, but my own view is that why not use a rod gnomon and make life a lot easier? There is a serious disadvantage of a rod gnomon, which I kept quiet about, which is that you'll poke your eye out, but you can poke your eye out on this one. So an advantage of the vertical spiky gnomon is that it does keep the pigeons off the dial a bit. If you don't like birds on your sundials, that's a good thing to have. Right, well, I think, do have a look at Martin's survey and tell me what you think.
Yes, some statistics. So there were 37 participants during our follow-up event.
Oh, well, that's good.
Yeah, that's a record number so far for us. But so far we have just 5 responses to our survey. And actually, we would like to have a bit more.
Yes, if you can fill in the survey.
Please go to chat, copy the link, and you can fill the survey also after this event. So we would be very grateful to get feedback on the format and length of this follow-up, and so we could make those follow-ups even better next time.
Absolutely right. So you go to the chat feature, then you click on the link and you can fill in the survey. You can do that now. It is very easy.
Yeah, we'll finalize this call
and
within minutes, but you can fill the survey also, let's say, a bit later or tomorrow or so, but I just keep the link with you.
Yeah, absolutely.
I found John's article.
Yes.
It's actually in the NAS publication in the compendium, volume 15, number 4, December 2008. And I think looking at the diagram, you're right. He's moved the gnomon right to the south.
To the edge.
Almost at the edge, yeah.
Yeah, that's
Okay.
right. I mean, always.
Could you share possibly the screen?
Ooh. I have no idea how to find it. Hang on a moment.
Yeah.
You carry on talking and I'll see if I can find it.
It's in the middle. It's a green button.
Yeah, but I've got to put the dial. Well, I need to find the actual
Article.
article.
Oh,
How do I
okay.
do that?
You have to go to the website, whether you can find it. I don't know.
Okay. So I
No,
thought
it's on my computer.
okay, I thought it's open.
But it's on your
No.
computer.
Yeah.
Mhm.
Right.
What do I do? If I open it on my computer and then hit share screen, does that work?
That will work. Yes. Well, do it. Yes, that's right. Or no, do it the other way
Okay,
around.
so-
Hit share screen, and then go to
Bear
your.
with.
You click share screen.
Let me get the article first. Is it triple? Okay, share screen. Oh, that says share screen.
Yes. Or click the share screen again.
Again.
Yeah.
You should select which screen if there are
And
several.
you can see when you go share screen, you will see your screen, and you'll see all your windows which you've got open. Then you click on the one which has the picture of the.
I've no idea which has it one. Finder. I have no idea what happens to desktop one. God knows what I'll be sharing with you, but allow Zoom to
Some of
share
your
screen.
really deep secrets.
Oh. No,
No.
that's not working. It's just taking me into settings.
Oh,
However,
okay.
we can write down the. But what did you say, November?
Which issue is it of the compendium?
It was 2008.
Did you say 2008?
Yeah, December.
Yeah, 2008. No. It's not working.
Which volume?
Volume 15, number 4.
15.4. Okay.
That's for December
December
issue.
2008, page 14.
That's a nice little challenge.
Frank, if I emailed it to you, could you show it?
If you email it to Martin, you probably do.
I think it will be shown by Fred. Yeah, if Fred asked. Yeah. No.
Yeah. Let's see. Page.
Yeah.
Page 14.
No, page 14. There isn't any image.
It says page 14 at the bottom. It might not actually be physically page 14. Oh, I know possibly why.
If it's counting
hang
the
on,
cover.
hang on, Martin.
Oh,
Should I
okay.
send it to you?
All right, there, I've got it. It's page 12 of the
Okay.
thing.
How odd, it's page 14 on mine.
Yeah, because they're counting the front
Well,
cover.
it's the 14th page of the file.
It counts the title pages as well.
The front cover counts as page 1, and the inside front cover counts as page 2. Then page 1 becomes page 3, and so on. Sounds as though Fred's going to solve the problem.
Fred, could you share it with us?
Well, the question is,
Figure
have you
2.
got?
Ooh, here we are.
Oh.
Yes.
Oh.
That looks like it. Looks very warm.
That's the page.
And what latitude was it for?
39, 19, 8.7.
Yes. And that.
There you go.
Yes, he's got north at the bottom. And his gnomon clearly goes right up to
The
the
top.
yeah. Oh yeah, this is clearly a multi-purpose instrument.
He calls it a triple horizontal.
Yes, I'm willing to accept that. Oh, that's really good.
Latitude 39 degrees.
Yes. Cool.
And the stereographic dial is actually very small. So the vertical edge minimal is only 1/4 of the diameter. Compared to the polar edge, it's really small.
Yeah, I think the dial is huge, if I remember rightly.
So it's more than your 95 millimeters.
Yeah, and it's got a most beautiful gnomon. If you can you go onto the next page, Fred, and see the gnomon?
Yeah, I think so here. Let's see if we go. There you go. Here's the gnomon. Wait, can you all see that?
Actually, we see the same image, I guess.
No.
Is it,
Ah,
perhaps it's latency.
okay.
Or you should reshare if it's in another file.
Yeah, I'm gonna. Let's see. Gotta bring back my Zoom.
Yes, this system isn't altogether user-friendly, is it?
I'm trying to find the size of the dial while you're doing that.
Here we go.
That would be a large and heavy piece of brass.
Yeah, because he talks about having to ship it to the US, crated up. Oh, 27 inches diameter.
Yeah.
The dial plate is 5/16 of an inch. There you go.
Golly.
There's the
That's-
gnomon.
That's actually
Oh.
a pierced gnomon. I think it's pierced and the red bits disappear. If you're with me.
Yeah.
So that red background is not really.
It's not there. It's taken
Yeah.
out. It's yeah, he's got another picture on a later page
Is that a
of
spider?
yeah, the spider's lovely. It's got a picture of the a Thomas Tompion dial in Kew Gardens with a very beautifully pierced gnomon, and he says that there you go, and that was his inspiration for the gnomon. So
Yes. Yeah, I entirely accept that these gnomons do have a certain facet to them, which is lacking with a rod dial, a rod gnomon. But they're beastly fragile and they're beastly easy to beastly problem with vandals. So
well, John's dial wasn't for, it was for a private individual.
yes, if it's for a private individual,
hopefully it wasn't get vandalized.
Yes, but you can get coyotes. You get wild animals jumping on it. Yeah, that's jolly good. Yes, well, I will dig out that article and read it. Otherwise, I think that's it for everybody. Unless anybody has any suggestions, but please write to me. Lovely to see you all. And same again sometime, I suppose, in April, all being well. So, yep, goodbye to everybody.
Bye-bye.
Okay.
Bye-bye.
Thank
Thank
you.
you.
Cheerio.
Goodbye.
Cheerio.